Today's lesson is not going to be in the book, so you're going to need a piece of paper. The reason it's not in the book is because what we are reviewing today was done in previous years. So we're going to just take a step off the highway here before we move on in equation solving in 8th grade. And we're going to talk about solving equations that have like terms and distributive property. The reason we need to do this is because as we move forward in the next section in our book, these are going to show up inside the equations and they assume you already have those. So again, we're just going to take a step to the side today to just kind of review these ideas. So our objective today is to solve equations with like terms, which you would have practiced with IXL, remembering who goes where, and then also distributive property, which will remind you this little rainbow over here, the rainbow method that you used in both in 6th and 7th grade. So we're going to start with the like terms, and then we'll talk about distributive property in a second. So when you look at this equation, the first thing you should notice is you can't kind of Woodruff bubble because there's two x terms. Well, we just talked about that happening in our last 8th grade section in the book, but notice that they're not on opposite sides. They're on the same side of the equation. And if they're on the same side, you're going to just combine them using like terms, the ideas that we were talking about in our IXL practice. So, and we also talked a little bit about it at the start of our last section, the 3E lesson. So the first thing we're going to do is if you're not sure what to do with the 3x minus the 4x, remember you can change this. You can rewrite the subtractions. So the 3x is going to stay positive, the minus becomes a plus, and the 4x becomes a negative 4x. In other words, a minus and adding a negative are the same things. Now, some of you like to see it this way, and the other, half of you is going to like it this way. And it really doesn't matter as long as you do it correctly. So 3x minus 4x, oh, by the way, 3x plus a negative 4x, we're just going to combine those. They're on the same side. We're not going to do opposite operations, and you should get negative 1x. At this point in time, we're at a two-step equation. Here we go again. Here comes the Woodruff bubble. We can do that now because we have only one variable term, and we're not going to touch the negative 1. So we're going to undo the subtraction first. We're going to subtract 6. And oh, by the way, you can kind of see what I'm doing over here in English. I'm going to subtract 6 from the left. I'm going to subtract 6 from the right. Negative 2 minus 6. I want you to think what that is, and please check it in the calculator. We didn't touch the bubble, so we're going to bring that down. There's our zero pair, which we're not going to write the 0 because negative 1x plus 0 is negative 1x, and negative 2 minus 6 is negative 8. Now, you might think you were done, but watch it. There's a negative 1, not a positive 1. The opposite of multiplying by negative 1 is to divide by negative 1. What is a negative 8 divided by a negative 1? Think it, check it in the calculator. And do you see that it's 8? Now, in order to check it, remember we have to go into this original equation. We're not going to check it in this one. We're going to go right to the top. Because if we make a mistake from here to here and we check it in that kind of in the middle, we won't catch the mistake. So that 8 is going to take the place of the x there and there in the original. So 3 times 8 minus 4 times 8 plus 6, does it equal negative 2? Now, this is a big PEMDAS, order of operations problem. So you're going to go left to right, but there's no parentheses, no exponents, but you're going to multiply or divide as you go left to right. So 3 times 8, we're going to write down. That's 24, but you're not going to minus the 4 yet. What you are going to subtract is 4 times 8, which is 32. So let me just show you what I mean there. So the 3 times the 8 becomes the 24. You hold on to the minus. 4 times the 8 becomes the 32 plus 6 equals negative 2, or we hope it equals negative 2. And now we need to go left to right, adding or subtracting. So 24 minus 32. And again, if you prefer to change that to plus a negative as you're working, that's fine. Think your answer, check it in the calculator, and you should see negative 8. And negative 8 plus 6 is negative 2. It sure is. And we have the right answer, which is 8. 8 is the only number that can replace those x's and make this equation true. So remember this map from the last video, and we had these blanks sort of here. So I'm just showing you the order. Now, a map, you have to do things from one to the next to the next. You don't jump from step 1 to step 6. So the first thing is you're going to change your subtractions to plus a negative. That's your same change. You don't have to do that, but if you're finding you're making mistakes with subtractions and negatives, try changing those. We're going to skip over these two right now. The next thing you're going to do is look for like terms on the same side like we just did with this equation. The 3x and the negative 4x, they're on the same side, so we're going to combine them using the same operation that's there. The next thing we're going to look for is there a variable on both sides? If there is, we're going to do what we did in the last video, and we're going to collect them on one using opposite operations since they're on opposite sides. And then we'll end up with either a 1 or a 2-step equations, which we did many videos again before. And we're going to undo the adding and subtracting, then the multiplying or dividing. And then we're finally going to check our solution, and we're always going to check it in the original problem. And we use our order of operations inside of that check. So here is one for you to try. So the first thing, if this minus is bothering you, you can change that and make it plus a negative. Then the next thing you're going to look for, here I'm drawing a line where the equals, is do you have like terms on the same side? And you most certainly do. So right now, you should be combining like terms. Do that and come back and let's see if you did that part correctly. All right, so we have 2x's and 3x's on the same side. You're just going to combine them to make 5x's. And then I have a 2 and a minus 6. You should have gotten 5x minus 4 equals 16. So there's the 2x and the 3x, and there's the 2 minus 6, which would give you a minus 4. And again, if you prefer to look at it as plus a negative and make this plus a negative, it's fine. To be honest, 50% of my students like it this way, and 50% like it this way. So, pick the way that works for you. At this point in time, we're at a 2-step equation. We're not going to touch the coefficient of the variable, but we are going to undo the subtraction by adding opposite operation, making a 0 pair here, and we'll end up with a 5x equals, well, that's easy. It's all positive 20. And then to undo multiplying, we're going to divide by 5 and get our answer of 4. What's the next thing we have to do? We need to check it. So we're going to put 4, but back in the original. Back in the original. And there is that original, but the x left and became a 4, and this x left and became a 4. Now, guys, order of operations. Don't just start going left to right. So we only have multiplying, adding, and subtracting. So we're going to multiply first. 2 times 4, write it down. Plus 2, plus, and now 3 times 4, write it down, and then minus 6. There's the 2 times 4, plus 2, plus, there's the 12. And now everything's adding and subtracting, so it's the same rank, so you can just go left to right. 8 plus 2 is 10. 10 plus 12 is 22, and 22 minus 6 gives us the 16 we were hoping for. Is x equals 4. Okay, so this one is going to kick it up a notch where we're going to have not only like terms, but also a variable on both sides. So what I would like you to do right now is to look at the left and look at the right and see if you can combine like terms to start. Just that first step. Again, if you need to change these, change these minuses to plus and negative, go ahead. But just right now, combine up like terms on the left and the right. Now, there might not need to on one side, but there's definitely one side here that needs some help. Okay, let's see how you did. So what I did start by doing is did the same change. So you'll see the negative 8b plus 11 equals 4 plus 4b, and that minus became plus a negative 3, and that minus became plus a negative 2b. Again, yes or no, do it if it helps you. Now, here's the equals. If I look at the left, the negative 8b and 11 are not like terms, they have to stay apart. But on the right, we have two pairs of like terms. The constants, the 4 and the -3, can be combined. 4 and a -3 added together make 1. And 4b and a -2b combined together make a positive 2b. And that's how our equation starts to clean up, just by combining the two pairs of like terms on the right. And now we're back to the last video. So I'd like you right now to solve it and see if you can find an answer for B. Now remember, these guys are on opposite sides. So when we do opposite sides, this is where we talked about having a choice, and you're going to combine them using opposite operations. So go ahead and solve this and come back and we'll see how you did. Okay, so I started by adding 8b to both sides because I wanted to stay positive for the coefficient in front of the b. You could have subtracted 2b and still get the same answer. And if you did that, just hang on for a second and we'll see how you did. This makes a 0 pair, so 0 plus 11 leaves 11 on the left-hand side of the equals. 2b plus 8b makes 10b, and then the plus 1. We're now at a two-step equation. We're not going to touch the 10. We're going to Woodruff bubble the 10b, and we're going to undo adding 1, which would mean to subtract 1. And 11 minus 1 gives you 10, and that equals 10b plus 0, which is 10b. The opposite of multiplying by 10 would be to divide by 10, and we got a really nice answer here of b equals 1. The reason I like 1 is because it's easy math in the check. Speaking of the check, we're going to take this black equation here, and every b becomes a 1 times a 1 times a 1 times a 1 in the original equation. And now I'm going to go left to right, doing order of operations. Now I'm going to multiply. -8 times 1 is -8 plus 11 equals, do not add. We're going to take 4 plus 4 times 1 is 4 minus 3 minus 2 times 1, which is 2. So you should do the multiplications first. And now, because they're adding and subtracting and they're in the same rank, you can just go left to right. -8 plus 11 is giving us a target of a 3. Now over here, 4 plus 4 is 8, and 8 minus 3 is 5. Whoops. And 5 minus 2 is 3. And we are very excited because our b equals 1 is the correct answer. So there's a couple of examples of equations with like terms. Now we're going to do a quick reminder of the distributive property. And basically with distributive property, whatever number is outside the parentheses is going to be distributed, multiplied times the group, everybody that's inside the parentheses. So see how the A is going to be multiplied by the B, but the A is also going to be multiplied by the C with the addition in the middle. It's kind of easier to see with numbers. So if you look down here, see the 2 is going to get multiplied by the X, plus the 2 is going to get multiplied by the 3y. 2 times x will give you 2x, and 2 times 3 would be 6y. And when we get to this next spot, a lot of people will say, well, can't I make that like 8 of something? But remember, they're not like terms, so they have to stay apart. Now over here, we've got -4 times a group that has a subtraction. And sometimes people have a hard time seeing this. So again, we could same, change this. We could change that minus to plus a negative. -4 times 5 is going to give me -20, plus -4 times -2. A negative times a negative would be a positive 8y. So when I do that multiplication, I'm looking at that. And no, we're not going to make this -12y. These are not like terms. This is a constant, and that is a variable term. They stay apart. The one that confuses people sometimes is it's the one that looks the easiest. It's like minus the group. It's a minus outside here. You need to remember that there's the invisible 1. What are you distributing? It's a -1. And when you distribute a -1, when you have a minus in front of the group, everybody gets subtracted. Everybody's signs change, basically. So when you take -1 times x, you're going to get a -1x, where it was positive, and -1 times the 7 is going to give you sort of a -7. And when that happens, basically what happened is the group signs changed. So it was x plus 7, and now it's -x plus -7. By the way, this is the same thing as -x minus 7 if you kind of reverse that same change. Adding a negative is the same thing as subtracting. These two are the same answers. I accept them either way. I'm just letting you know that this is sort of the cleaner answer. So that's the distributive property. So we're going to start by putting the distributive property back into our equations, which we actually have done before, and like I said, in earlier grades. But right now, how do I know there's going to be distributive property, Mrs. Woodruff? It's the parentheses. So when I see those parentheses in my equation, I don't start doing anything. The first thing I'm going to do is I'm going to multiply that 6 times the t plus 6 times the 5. So I'm going to distribute the 6 and basically clear the parentheses, because when I multiply 6 times t and the 6 times 5, I'm going to get 6t plus 30 equals -36. I am absolutely okay if you need to write this step, and I'm absolutely okay if you can go right from here to here. So 6, rainbow it over to the t, 6 times t, plus take the 6 and rainbow it over to the 5, 6 times 5, which is 30. And here we are again at a two-step equation. We're going to Woodruff bubble and not touch the 6. The opposite of adding 30 would be to subtract 30 from both sides. The 6t is going to come on down, plus a 0. We don't have to write that, so it's just 6t. And now I want you to think, what is -36 minus 30? I want you to think it, and then check your answer in the calculator. Did you get -66? And again, to undo that one step of multiplying by 6, we're going to divide both sides by 6. And our answer, we think, is -11. Now, if you guys have fallen asleep, I need you to wake up, because we need to talk about the check here. Same idea, the -11 is going to take the spot of the t, but I need you to listen right now. We do not do distributive property in a check. So we're not going to have rainbow. If you make a mistake doing the distributive property, guess what? You're going to make the same mistake in the check. We don't use distributive property in the check, so we can make sure you did it correctly. So you are going to use your order of operations, and the first letter says P, parentheses. Matter of fact, the way I'm going to show you is easier anyway. So you ask yourself, what is -11 plus 5? I'm going to do what's in the parentheses first. Think it, check it in the calculator. What is a -11 plus 5? And you should see -6. And now we just have one operation, 6 times -6, and it works. Our answer is -11. So just to kind of finish off the map, the first thing you're going to do is change your subtractions to plus a negative. That's your same change. And like I said, 50% are going to want to do that, and 50% don't. You need to do it if it helps you to make sure you keep your negatives and minuses straight. The next thing you're going to look for is parentheses, and you're going to do the distributive property to get rid of those. We're going to jump over 3. Next, you're looking for, are there like terms on the left? Are there like terms on the right? You're going to combine them. Next thing, is there a variable on both sides? That's the next thing we're going to do. And then we'll be solving our 1 or 2-step equation that we are now becoming pros at. And don't forget to always check it in the original, and you use order of operations to do that check. So let's do this one. Can you right now change the subtractions on this one? Let's just do it all together once to see if you like it. So we're going to keep the -2, but in here, that minus is going to become plus a negative. So rewrite this on your paper. And now I'm going to ask you to solve this one and see what you get for h. Oh, by the way, the next step is to do the distributive property. Let's see how you did. -2 times h write it down. That's negative 2h plus a bad thing happening to a bad person is a good thing. A negative times a negative would give you a positive 6. We're now at a two-step equation. We're going to Woodruff bubble here and don't touch the negative 2, but we are going to undo the adding 6. We're basically doing order of operations in the opposite direction to undo them. So we're going to subtract 6. Don't add 6. You have to do the opposite operation when you're doing opposite sides. Negative 12 minus 6. Think the answer. Please check yourself. And did you get a negative 18, right? And then you should have divided by negative 2. Don't cut that arm off the number. And your final answer should have been positive 9. When you did the check, the 9 goes back in the original, and there should be no distributive property in the check, okay? You're going to do order of operations, parentheses. 9 minus 3 is easy. It's 6. And then negative 2 times 6 shows us that 9 is the answer. Remember, no distributive property in the check. Okay, this is the final one of the day, and I'm not going to say a word, and I'm going to see if you can do it. So on paper right now, give it a practice. And if you need to, remember the first thing, if you want to change that minus. Second thing, distributive property. Then you're going to look for like terms, left and right. And then you're going to look for a variable on both sides. If you need to rewind back to see the map, go ahead. But right now, let's see how you do. Okay, we're going to do it one step at a time, guys. First thing I did do was I changed it. And I also put in the invisible 1 just to remind myself to tell you you can always do that. Okay, so we changed it. We changed the minus to plus a negative. Second thing, distributive property. 2 times 1y, write it down, plus 2 times negative 8, write it down. And that's what I have on the left, and that's what I have on the right. Notice that I have a variable on both sides. So I can either subtract 2y, or I can add 4y. I'm going to choose to add 4y because I like to stay positive for the coefficient. 2 and 4 make 6y. And I'm looking at this two-step equation. Now, sometimes this confuses people when there's a plus and negative. We're not going to touch the 6y. Basically, you're looking to make a zero pair here. So the easiest way is to see this as that negative 16. You're going to have to add a 16, and there is your zero pair to get rid of him. So 6y is going to equal 24. And then the opposite of multiplying by 6 is to divide by 6. And did you get y equals 4? I'm going to put the 4 back up in that original equation, and we're going to basically have amnesia that we do not do distributive property in the check. We are looking to do PEMDAS, so it's easier. Anyway, 4 minus 8 in the parentheses. Did you put negative 4? And 2 times negative 4 is going to give me a negative 8. On the other side, negative 4 times 4 is negative 16. And negative 16 plus 8 is going to give me negative 8. And that shows that y equals 4 is the only number in this original equation that'll keep that equation true. So we're mixing everything up today, guys. We're putting some things back in, like terms and distributive property. And basically where we're heading next is just mixing up all of our equations to do, more complicated equations. You might remember a few videos back that there was a picture of me with the face slap, and I told you that, we would get to equations that were far more complicated, and we're heading to that page really soon. So today we reviewed like terms and distributive property. When I see you next, we will do some practice. It will come on a worksheet because, again, our book assumes this is already in your toolbox. Guys, I hope you have a great day.